Good morning. It is Monday, March 30th. We actually have a quick little lesson, and then we have day one of a 2-day lesson after that. And the first lesson is I can find the fourth point to create parallelograms by counting on the graph. So everything we're going to be doing here, we're doing the graph. It's pretty straightforward. It's going to take just a few minutes, and then we're going to utilize this within a bigger problem. So let me get my pen going here, and let's take a look. Oh, that's going to be a problem. So it wants me to find the fourth point to make this thing a parallelogram. So I've got A is negative 4, 1. B is 2, 3. C is 1, negative 1. Now, I know the letters must go in order. So if it's A, B, C, D, then D's got to be somewhere over there. So now where exactly is it going to go? Well, since I know in a parallelogram that opposite sides are congruent, whatever I do to get from here to here, I'm going to do the same thing over here. So to get from B to C, I'm going down 1, 2, 3, 4, left 1. From A, I'm going to go down 1, 2, 3, 4, left 1, and that's D. That's it. I'm counting whatever I do to get from B to C, I'm counting to do the same thing to get from A to D. The coordinates of that point are negative 1, 2, 3, 4, 5, negative 3. That's it. We're just counting from the same thing from A to D as it is from B to C. That will make it a parallelogram. Number 2. I've got A is 5, 4. I've got B is 8, negative 2. I got C is 7, negative 5. Again, A, B, C, it's got to be somewhere over there. So whatever I do to get from B to C, I'm going to do the same thing to get from A to D. So if it's down 1, 2, 3, left 1, down 1, 2, 3, left 1, that's D. Does it look right? Sure does. The coordinates of D, 1, 2, 3, 4, 1. Why don't you try number 3 and 4 on your own right now? Okay, I'm going to give you a couple minutes. Try 3 and 4 on your own. So you shouldn't be watching the video. You should be trying 3 and 4 on your own in your quadrilateral properties packet. Maybe another minute or so. Okay. Whatever I do to get from B to A, I'm going to do the same thing to get from C to D. So from B to A, it's left 1, 2, up 1, 2, 3, 4, 5. So left 1, 2, up 1, 2, 3, 4, 5. That's D. The coordinates of that point are 1, 2, 3, 4, 5, 6, 7, 1, 2. And draw it in, make sure it looks right. For 4, again, whatever I do to get from C to B, it's going to be the same thing from A to D. So it's 1, 2 to the left, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5. There's D. That point is negative 10, negative 2. We can draw it in. And that's it. What else do I got? So I got some rectangles or something here. So I wanted a right triangle. So this is very similar, but if I want a right triangle, I'm going to have to utilize the concept of negative reciprocal slopes. There's more than one correct answer here. All right, so these are the right triangles. So if A is 2, 3, B is 4, 2. Now, you got to know where the right angle is. It should tell you. If not, then there's plenty of answers you can give. But I'm going to put the right angle at B. I know that perpendicular lines form right angles. And I know that perpendicular lines have negative reciprocal slopes. So, if the right angle's at B, the slope of AB is down 1 over 2. So that means the slope of BC must be the negative reciprocal of that, which would be positive 2 over 1, which is positive 2. So from B, I'm going to go up 2 over 1. That's C. And you can see the right angle. Now, I could have gone up 2 over 1 again. I could have gone another up 2 over 1 and called that C. That's fine. It's still a right triangle. There's more than one correct answer. But I'll go with the initial one, which is 1, 2, 3, 4, 5, 1, 2, 3, 4. Again, there's more than one correct answer. I could have also applied the slope in this direction. As long as it has a slope of 2 over 1, it's correct. A is negative 2, negative 5. B is 2, negative 2. So, again, I'm going to start by finding the slope of AB. I'm going to give you a moment to find the slope of AB. Okay, that's enough. 1, 2, 3, 1, 2, 3, 4. So that means the slope of BC must be the negative reciprocal of that, which is negative 4 over 3. You have a choice of how you count that out. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. I'll put it right there. I can see the right triangle. I can see the right angle. The coordinates of C are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. That's it. The final thing here is rectangle. So we're going to do 2 examples for rectangle, and then I'll let you do the rest on your own. A is 2, 1. B is 3, 3. C is 7, 1. I mean, it's really the same thing that we just did with parallelogram. If I want D, I just have to be careful. No, there's really nothing to be careful of. If I'm looking at the order A, B, C, D's got to be somewhere over here. Count from B to A, down to left 1, down to left 1. That's my D. Here's my rectangle. 1, 2, 3, 4, 5, 6, -1. I'm not going to do anything more. It's really the same thing that we did. I also could have done with negative reciprocal slopes, but I think that's the easiest. So this is going to be a component within a bigger problem that we're about to do, and that's it. Again, I can find the fourth point to create a parallelogram by counting on the graph.